Hello everyone and welcome to Algorithms. Today we are going to see a beautiful algorithm called as the Dutch national flag algorithm, which makes use of two pointers to sort the array which have been specified by some constraints. So before starting, I want you all to subscribe to my channel if you are new and to hit the bell icon so that you get notifications for the new upcoming videos. Your support helps me to create new exciting contents. Okay, so let's get started with the problem. So the problem is given an array containing zeros, ones and twos, sort the array in place. So basically it is a sorting algorithm, but only the uniqueness is that the array contains only zeros, ones and twos, or you can say the array contains only three unique objects, and you have to sort that algorithm. And so, but what's the relation of that with the Dutch national flag? It is the flag of the Netherlands consists of three colors, that is red, white, and blue. And since our input array also consists of three different numbers, that is why it is called the Dutch national flag problem. So nothing as such, but just a story behind it. Okay, so let's see the example. The input is 10210. After sorted, first 0011 and 2. Again, the sample input is this, and output is this. Now let's see why we need this approach. So brute force, you can see that any in place comparison sorting algorithm will take a big O of n log n time, like heap sort, it will take big O of n log n time in place. So that is the best possible we can do with brute force, you can say, or rather algorithmic sorting algorithm which can do at best. So can we think of something other solution which will reduce the time complexity? Yes, actually the answer is yes. So let's see what is the optimized approach. So we can see here is that the array consists of only specified range of numbers, that is 0, 1 and 2. So you can use some non-comparison based sorting algorithms like counting sort, which will give you the time complexity of O of n, right? But it is a bit tricky and difficult to implement algorithm wise. Complexity wise it will give O of n, but implementation wise it is a bit tough. So by using two pointers, the algorithm, that is the Dutch flag algorithm, it makes use of two pointers and also gives you the complexity of O of n, and at the same time it is very easier to implement. So let's see when we can how we can implement this algorithm. So I hope you got the intuition behind using this algorithm. First of all, if you are going to use some simple sorting algorithm, it will take O of n log n time. You can use some non-comparison based algorithms because the range is satisfied, right? Because for any algorithm like counting sort or radix sort, the range must be given for the input array. That is what is the range of numbers that will be available. Here the range is for three numbers, so you can use counting sort, but it will have implementation difficulties, right? So with that we can use when we have the range is very much larger, right? Now here the range is just confined to three numbers, so we can use this algorithm which will solve the problem in O of n time. Also with it will have simple algorithmic complexity, right? So let's see how this problem is solved. Now this is the algorithm. It's very easy algorithm. So we'll see how it is solved. So we'll use two pointers to iterate over the array. The first pointer is as usual, that is the left pointer and the right pointer. And the two pointers will let us call them as left and right, which will point to start and of the array and end of the array as usual convention. That is the left pointer would be at start of the array and the right pointer would be at the end of the array. Now here is the main part. While iterating, what we'll do, we will move all zeros to the left of the left pointer and all our twos to the right of the right pointer, and all ones will be between the left and the right pointer. So what I mean to say is, before the left pointer we will have all zeros, after the right pointer we will have all ones, and within the left and right pointer inclusive we will have all ones. Okay, I guess I am mixed it up, so let me tell it again. Before the left pointer we'll have all zeros, after the right pointer we'll have all twos, and between the left and the right pointer inclusive we'll have all ones. So finally it will look something like this. So we'll have here all zeros, then here our left pointer, then all ones, then here our right pointer, and all two. It will be something like this, and even at the places of the left and the right pointer, I guess we'll have the ones, that is inclusive cases. So we'll see how we can solve this problem. I will show you the situation here. Suppose our array is 10210, right? Now my left pointer will be pointing at the start of the array. My right pointer would be pointing at the end of the array, and this is my I iterator, you can say. Now initially the ith position I have my value 1. So since at the left position I am going to have the value 1, I will just increment my this iterator, that is I. Now I am at this position here. Now I am at this position. and now my ith value is 0, right? Because I didn't do anything, because since as per the condition from here to here, you actually going to have this the value 1. So here also you will have the value 1, and here also you will have the value 1. So like zeros, then followed by ones, followed by twos. So before L there will be all zeros, and after R there will be all twos. So I hope this thing is clear for you. Now see, the first step here is, first I encountered 1 here. Then I went, so I just incremented my I to the next value. So now I got 0. Now as per the algorithm, what it says is that we need to have our zeros before the L, that is before the left pointer. So what I'm going to do is I am going to swap these two terms, that is I'm going to swap 1 and 0, and I'm going to increment my left pointer. So what it will be here, so my I am going to swap these two terms. So my 0 will become 1, and my 1 will become 0, and finally I would increment my left pointer here. Now finally I would increment my left pointer, and my L will be here. So as you can see right now, this part of array is sorted here. This part of array is sorted, that is at L I am having the starting of 1, and the before L I am having my 0, until where my I is there, till that part my array is sorted, right? Now I move my I to the next value. Now my I comes here at 2, right? Now my I comes here at 2. Now I see that at this ith position I am having the value of 2, and as per the case what I need to do is I must swap, that is all the twos, all the r's that must be there, all the r's must be after the 2, right? So what I am going to do, I am going to swap again this and the value at which my r is pointing. So I am going to swap these two terms, right? So what is going to happen is this 2 will become 0, and this 0 will become 2, right? And I'm going to decrement my r here. Now I will have my r here, right? Now see, so I guess till here it is clear. What I did is, initially here the value was 2 and here the value was 0, and since you can see that what I mean to say, since here you can see that since the value here is 2, what I just did, I swapped my value with the value pointed by the r, and I just decremented my r here. So that is what you need to do here. So as you can see, before L there is all zeros, and before R, or you can say after the R, there the value is 2. So till now the value this previous and this next, from left and the previous and from right and the next, everything is sorted here. So let me clear this arrow. Now as here, one thing you should observe is, after swapping for the left side I incremented my ith pointer, but once I did swapping for the right side I am not going to increment my ith pointer. Why? Because once the swapping is done, there might be two possible cases. That is, once the swapping is done, let me write here. See, once the swapping is done, we'll have two cases. That is, either that position 1 will be there, or at that position 0 will be there, right? Because something either 1 or 0 you are going to swap with 2, right? So you need to check again, so as to maintain the constraint for left and the right pointer. Why? Because if I would have swapped and increment my ith pointer, you will see that my left would be here, and at the same time I would have 0, which is to the left side of L, right? So that would violate my constraint. So after swapping 2, you just remember, after swapping 2, don't increment the ith pointer, right? Don't increment the ith pointer. So once the swapping is done between 0 and 2, I am keeping my I as it is. Now what I'm doing, I'm again checking. Now at the ith position, what I'm having, I am having my value 0 at ith position. This is my, I am having my value 0. So what I'll do, as previous, I would swap it with the value pointed by L, and increment my L pointer, right? So here I'm going to swap my value. So what will happen is, this 1 will become 0, and this 0 will become 1. This 0 will become 1, and my L pointer will get incremented here. So as you can see again, the whatever the values are before L, those are zeros. Whatever the values are after L, after the R, or after R, those are 2. And I'm going to increment my ith pointer here. Now I am at ith pointer. As you can see here, the value is 1, so I'm going to do nothing. And finally I come to this end. and my array is sorted, as you can see 0 0 1 1 2. So if in short you have to compress this algorithm or the steps, you can see first check for first you can check first check for 0. So if it is 0, then what you are going to do is just swap with L and increment I and L, right? Then what you are going to do is then check for 1. So if 1, just nothing, then increment the I, right? Nothing you are going to do. Then here check for 2. If it is 2, then what you are going to do is you are going to a minute, you are going to swap with R and decrement R. Yes, because you know the left pointer is going to go in the forward direction, R pointer is going to do in the reverse direction, decrement R. But here, but don't increment I. Why you should not increment I? Because once swapped, uh, at ith position, we can have either 1 or 0. So that must be checked. So that must be checked if it violates the condition. Right, because you saw here once I swapped here with once I swapped 0 with 2, here at this position I was having 0. See, once I swapped here at this position I was having 0, at this position I was having 0, and at this position I was having 1, and my L pointer was here, right? So if I would have just incremented my I pointer to go ahead, this condition would this 0 would have been never been replaced with the value I needed, right? So this condition would have failed. So whenever you just swap it to, you don't increment the I pointer, and you again check for 0 or 1. Okay. And finally, again, what is next? And this is for do, and do this and this, what you can say, repeat, what you can say is repeat until L is or you can say I is less than equal to R. You can say here in this I went till here, I went till the end of the array, but it is not necessary, because at wherever R is pointing, all the values before it are actually sorted, right? Since here my R was here, all the values after it here, so not before, after the R, they are actually sorted. So if I would have just stopped till here, that would be also okay. So repeat until I is less than equal to R. So this is the short and this is the pseudo code for this algorithm. So if you have understood this algorithm, I want you to go to this link. I will put this link into the description section and go and solve this problem. Now once you have solved this problem, do come back here for the solution. So now I will show you the solution. It is the same implementation. So the solution is as follows. See, what we are doing is here, what we're doing, this is like my left pointer and this is my right pointer. So left is 0 and right is to the end of the array, right? So as told that zeros will be to the left of the left and twos will be to the right of the right, and finally ones will be in the middle. So you can consider this as a three-way partition, right? So initially what I'll do, while I is less than equal to right, as I said, first for the case of 0, if my num of I equal to 0, I would do the swapping. This is the Pythonic way of swapping, but this is just swapping between I and the left indices, and I will increment my left and I will increment my right. So this is over and this is over. Now for the case of 1, if my number is just 1, I would just increment by 1. Else what I'm going to do is I'm going to swap the number for the ith and the right value. This is the swapping here is done, and I'm only going to decrement my right. Just take here a condition, that is I'm not incrementing my I, but I'm just decrementing my right, and this everything is going to take place till I is less than or equal to right. I hope you got this. So with this the algorithm ends. So I hope you understood this algorithm, that is the Dutch flag algorithm. It is a very simple sorting algorithm, but only applicable when there are only three unique objects into the array. So that's it for this video. I hope you liked the video. Do like, share, and subscribe to this video and to my channel. So thank you. If you have any doubts, write them in the comment section.